every row inside your delta table gets a unique row ID and row commit version. So if you combine both of these concepts together, you will see the benefit. Okay. So before row level concurrency, what would happen? You can imagine there's a file A with 4 rows and deletion vectors is all 0, meaning all rows are active. Now, if you delete one row, essentially in the deletion vector, there could be a change and you mark in the deletion vector as that row 3 has been deleted. So that's just soft delete or deletion vectors in action. Now, next step. Suppose if you have two transactions trying to update different rows. So in this example, say T2 transaction trying to update row 0. Without row level concurrency, what would happen is if T1 has gone through, then T2 who is trying to update the same file would get conflict, it would be rejected. But if you add the row level concurrency features, which basically has the row ID and row commit version, it would recognize that T1 has committed and T2, when it's trying to commit the file, it will see something happened to this file. However, it impacted a different row. That's why I don't need to fail. That's why it can continue going on. So that's how the concepts are coming together. Hopefully you can see that once you have the deletion vector, which gives you soft deletes, meaning you don't have to rewrite the whole Parquet file. And then you add the concept of row level concurrency, which basically gives each row a row ID and row commit version. Then you can allow two transactions or multiple transactions to write to the same delta table and they won't conflict with each other as long as they are altering different rows.